So let's examine the following problem in which we're going to use the given information to calculate the distance two waves have traveled. Let's suppose that a certain string that has a mass of 200 grams and a length of 12 meters is connected at two ends to two walls as shown. So we have the mass of this string is 200 grams and the distance from one end to the other end is 12 meters. Now, a wave pulse is created at one end at time equals 0 seconds. So at time equals 0 seconds, we have one wave pulse. Let's call it wave pulse number 1. That's created on the left side. And let's say it has velocity v1. Now, 15 milliseconds after wave 1 begins to travel, a second wave pulse is generated on the other end of our cord. And let's say the velocity of that wave pulse is given by v2. Assuming the tension in the cord is 300 newtons, calculate where the two pulses will meet. So we essentially want to find the distance from one end, let's say from the left end, to where our two pulses meet. So let's begin, and in part 1 we essentially want to calculate what the velocity of each of our two pulses is. So notice that our two pulses are traveling in the same exact medium, in the same exact cord. And that means the velocity of each of the wave pulses will be exactly the same. So v1 is equal to v2, which is equal to, let's say, to v. Now, how exactly do we calculate the velocity of a mechanical wave inside a cord? Well, we have to use the following equation. The velocity is equal to the square root of the tension in our cord divided by mu, which is the mass per unit length. So our mu is m divided by L. So we know what the tension in our cord is. It's given to be 300 newtons. We know what the mass is. It's 0.2 kilograms. So we simply take 200 grams and divide it by 1,000 to convert it from grams to kilograms. And our length is given to be 12 meters. So we plug that in, we take the square root, and we find a velocity of 134 meters per second. So this is the velocity of both wave pulse number 1 and wave pulse number 2. Now, let's look at diagram C. So we know that after wave pulse number 2 begins traveling in the opposite direction, wave pulse 1 has already traveled a certain distance. So we want to calculate what that distance is. So to calculate what that distance is, we simply multiply the velocity of our wave pulse number 1, which we found in part 1, by the time value of 15 milliseconds. So we have v1 times t is equal to, well, v1 we said is simply v. So this is equal to v times t. So our v is simply 134 meters per second, and our t is, well, it's 15 milliseconds divided by 1,000 because we're converting from milliseconds to our seconds. So we have 134 meters per second multiplied by 0.015 seconds, and that gives us 2.01 meters. So that means this distance that wave 1 has traveled before our wave 2 has begun to travel is 2.01 meters. So now we're in part D. So we essentially want to determine what this distance is and what this distance is. So we're looking for what the value of x is. So let's say that the distance from where wave number 1 begins at this point to where they meet is given by x. And that means the distance from this end to where they meet is, well, it's simply 9.99 minus x. Where do we get 9.99? Well, we simply took this quantity and subtracted that from 12 meters. And that gives us this entire distance. So this entire distance is simply 9.99 meters. So But notice an interesting thing. Wave number 1 and wave number 2 have the same exact velocity. So that means the distance wave number 1 travels and the distance wave number 2 travels is exactly identical. So it's half. So that means x is equal to 9.99 meters minus x. So we bring x to the left side and we divide by 2 and we find that x is equal to 4.995 meters. So this distance is 4.995 meters and this distance is simply 9.99 minus 4.995 meters. So finally in part 4 we see that wave 1 travels, well it travels this distance plus this distance. So 2.01 meters plus 4.995 meters gives us 7.005 meters is the distance our wave 1 travels from the left side of our chord to where they actually meet. And wave 2 travels a distance of 9.99 minus 4.995 meters from the right end. So they meet right at this position, a distance of 7.005 meters from the left side of our chord.